So in order to simplify these, one of the parts of simplifying is to get rid of the parentheses. And we do that by using the distributive property here. And so for this first one then, I have to multiply that 10 into every single term. So for that first part, 10 times 3x to the fifth, that's going to be 30x to the fifth. Then I do the 10 times the minus 8x, so that's going to be a minus 80x. Then we do the 10 times 19, so that's going to be plus 190. And that's it. We're done. We can't do anything else to this. We cannot simplify it any further because none of these three terms here, remember terms are separated by addition and subtraction, none of those three terms are like terms. Remember, for something to be a like term, it has to have the same variable and the same exponent. And so that's why we can't combine these first two, because yes, they both have x's, but the exponents are different. And so we cannot subtract them. This is as good as it gets. All right, for the next one, we have to do the same thing here, just in this case, we're going to distribute in the x squared. Well, here we might need a little refresher, because I'm going to end up multiplying x squared times x to the fourth. And there is a nice little rule. The problem, though, with just remembering a rule is that if you forget the rule, you're in trouble. Because if you forget the rule, then it's just a matter of, I'm just trying to remember something I memorized. But if you remember why the rule is what it is, it makes it a lot easier. So, if I do x squared times x to the fourth, remember x squared just means x times itself. And remember that x to the fourth means x times itself 4 times. And so if I'm going to multiply x squared times x to the fourth, notice that's just 6 x's all multiplied together. Hence the answer is going to be x to the sixth. And so if you forgot the rule, now you can remember it and you can see what happened, because we took our 2 and our 4 and we added them to get 6. And so that's our first part there. It's going to be 6x to the 6. This 6 just becomes this 6 here. All right, then we go and we multiply by the next one. So I'm going to do x squared times this 4x, so that's going to be 4. And it's going to be 4x to the power of what? 3, absolutely. Because there's like this invisible 1 as the exponent on the x. So if we're thinking of just adding the exponents, x squared times x to the first, the 2 plus the 1. Or, of course, you could also think of it written down here like we did before, x squared times x. Notice that's 3 x's all multiplied together. All right, and then finally I have to do the x squared times the 11. Now when we do this, notice there's no x's here that's going to change anything, and there's no numbers here that's going to change anything. And so it's just going to stay 11x squared. And that's our final answer. Now, we did this practice of simplifying using distributive property because today we're going to be building on this practice. We are going to be taking a look at factoring, which really factoring is the exact same process except in reverse. Because factoring, I'm going to give you something that looks like this, and I'm going to tell you to write it instead like that. So simplifying, multiplying, get rid of the parentheses. Factoring, you introduce parentheses. Let's take a look at an example of that. Go and write down this problem. So in order to factor this, we know we're introducing parentheses. So in other words, I know I'm going to have something out front of a set of parentheses, and inside my parentheses I'll have like a couple minus signs because of these minus signs here. And I know that much at the start. That's what we have to end up with if we're going to factor it. Notice it's that distributive property that we just did, but backwards. It's all a matter of figuring out what is that number that goes out front. And that's a matter of what can I divide all 3 of these terms by. Now I always want to find the biggest number I can divide them all by. So like I could divide them all by 2, but we can do better than that.
20.
The biggest we can do here is 20, yes. And so I'm going to factor out a 20. So that means I start by writing the 20 out front of the parentheses. And then I'm basically going to take every single one of these terms and divide them by 20. So 60x to the 8th. You notice that if I divide it by 20, the x to the 8th won't change. That's still going to be an x to the 8th. But the 60, of course, that'll change. What's 60 divided by 20? 3. So that just becomes 3x to the 8th. Now, if you ever want to check and make sure that you did it right, well, theoretically, if you multiplied those back together, you should get what you started with. And indeed, that would be the case. So you ever want to check yourself, that's how you can do it. All right, now the minus. 20x divided by 20. What will that leave me?
X, negative x.
That will be, well, 20 divided by 20 is 1. Some people will write 1x. Yes, that technically is correct, but of course, it's a little bit more than we need. So I would rather it actually be written just as x. Very good. And then the minus stays a minus here. Then we just do 100 divided by 20,
4.
which is 5. Now that we've gone through all 3 terms, we're done. We end the parentheses, and we have our final factored form. Alright, so you go to factor this one now. First thing we do is we look to see what can I divide every single term by. In this case, hopefully you saw it was the 7. And so I'm going to take the 7 and pull it out front of the parentheses, and then divide every term by 7. So 28x to the 9th. The 28 divided by 7 is 4. And then the x to the 9th is unchanged, because we're not pulling out any x's here. The plus stays a plus now. Then 70 divided by 7, of course, is 10. Then the x to the 5th stays x to the 5th. And then this is the part that's kind of tricky on this. And this is the part where every now and then I'll catch somebody off guard, because some people will say, and then that's the end. But it's not. Because notice, if I multiplied the 7 back in to that, all I'm going to get is this. There wouldn't be a plus 7 hanging on the end if I tried to put it back in. So there still has to be a plus and something's out there. So 7 divided by 7 is 1. And it's just going to be a 1. And so then this is our final answer, because we have to have something there at the end for us to actually distribute the 7 to. In the previous 2 problems, the factor that we pulled out of everything was one of the numbers that was actually part of the original expression. In this case, though, that's not going to work, because you'll notice like the 30 here, I can't divide 45 by 30, at least not without getting a decimal, and we do not want decimals here. We keep everything as an integer. And so, we have to then look at it and figure out, what can I divide 30, 90, and 45 all by? The answer here is 15. And so, the biggest number we can pull out of every term is a 15. Now, as you looked at it, you might not have caught 15 right away. You might instead have caught 5 right off the bat. I want to show you what happens if that happens. What if you don't happen to see the biggest number right from the start? You go and you'd factor it. So we divide everything through by 5. So that gives me 6x to the 4th plus 18x cubed plus 9. But notice inside of my parentheses right now, the 6, the 18, and the 9. Notice they're still all divisible by another number. What can I divide 6, 18, and 9 all by? 3, absolutely. And so should you end up in that situation, you have 2 options. You can either say, uh-oh, they're still divisible by something, and you can go and you could restart the problem changing this number out front. Or you can actually just work from here, because we already know we have the 5 out front. Now we're pulling out a 3. And you could factor a 3 out of that last line. So then you'd write as 2x to the 4th plus 6x cubed plus 3. And then by this point, you're probably feeling a little paranoid, so you double check the 2, the 6, and the 3 to make sure there's nothing else that comes out. And yes, we're done. But then notice what that tells me. That 5 times 3 that's sitting out front, that means I actually could have pulled out the 15. And so I do the 5 times the 3, and I can just then make that into 15. We still get to our final answer that way. So if it takes us a couple steps to get there, that's fine, because we won't necessarily find the biggest number the first time every time. All right, one last problem. Everything we had done so far was a trinomial. That was 3 terms. But the same process works for any polynomial. So, factor this 5-term polynomial, please. Now, as you're looking for factors for this one, a great thing to do to start with, especially when there's so many terms going on, is I often will look for the smallest number, in this case the 12, and I look to see what that one tells me, because of course it can't be anything bigger than 12 that goes into everything else, because 12 is the smallest. So I think about, okay, does 12 go into all the other terms? Nope. It fails on the 18 and it fails on the 30, both over here. So it can't be a 12. So then I start shrinking down the 12 and I think about, okay, what's the biggest number other than 12 that goes into 12?
6.
And the next one is 6, so then I check 6. Does 6 go into every other term? Yes, it does. Okay, I got my winner, and I can bet that that's going to be the biggest that way. And so I'm going to be pulling out the 6 here. Now, you might not have come up with 6 right away. You might have come up with the 2, or you might have come up with the 3 going into it. That's fine, but you're going to have an extra step, because you're going to have to get to the 6 at the end. All right, and so when you then divide everything through by the 6, this is what you should get. 6x to the 7th minus 10x to the 6th plus 2x squared plus 5x minus 3. And then that's it, and we're done.